So today we're going to talk about meaningful animations. And you see already that I used like the most meaningful animation on my first slide. One could say that it's not meaningful at all. And we could agree, I guess. But you know, if I say that the purpose of this animation is to bring your attention to this particular world here, meaningful and highlighted, then maybe it's not that meaningless. And you know, speed of this animation, colors that I'm using here, will actually change the amount of attention, or maybe it's at some point it will be even destructive and it will be annoying. So it's an interesting way of thinking about animations where you have to like balance between what you want actually to achieve. All right, so my name is Oleksandr Sabov. I'm a UX engineer at IBM. UX engineer is actually a front-end developer who works together with designers really closely. So I'm still writing JavaScript, but mostly I'm working on animations, complex interactions, and performance and stuff like that. I'm working on SPSS statistics. This is an IBM product. It's a desktop application for statisticians widely used at universities. And here's our splash screen where this is, oh, all right. You barely see that, but it's all right. So one of the things that we built recently and open sourced at IBM is a carbon design system. So it's a traditional design system with open source components that everyone can use, but it also comes with guiding like how to approach motion, how to approach animation. And I want to show you a short video about from Carbon Design System that explains a little bit how we approach motion at IBM.
Motion brings our work to life. It communicates, guides us forward, and demands focus. Duo's approach to motion design embraces dichotomy, man and machine, organic and engineered. This duality has been distilled down to two modes: productive motion and expressive motion. Productive motion creates a sense of efficiency and precision, while expressive motion delivers enthusiastic and vibrant movement. Together, they create an essential dynamic and rhythm that combines the intuitive and the calculated, the flexible and the fixed. From timing and paths to choreography and consistency, motion creates engaging experiences that move us toward meaning, insight, and clarity.
All right, one of the key messages here that was at the beginning, that motion can bring the screens to life. So it can, you know, highlight things that you want to highlight, drive attention. And here I have a recipe for you, how to cook a great animation. And first thing, you have to find a good purpose. So there always should be something that you want to solve by doing animation, or what you want to help. And the second thing, you need to add a little bit of meaning. We will go through each of them a bit later. And last step, I guess, really important step, you need to serve animation cold, meaning that a laptop of your user should not burn down while it's running your amazing animation on 60 FPS using all the graphic cards and everything. So it should be cold, but still you should achieve 60 FPS. The point here is that, you know, if you cannot achieve 60 FPS, or you cannot make sure it's performant, then there is no point of doing this anymore. All right, so first thing is purpose. And purpose, if you check the world itself, it's actually a question: why do I do something? Why this thing exists? And if the answer to this question, because I can, like if you've created something, animation, just because you really like fell in love with the technology, or you just learned some new cool thing, and you're just like, all right, I'm gonna throw it in and use it everywhere. You've probably seen websites where people like get really excited about like animating text, and they're like, wow, that's so awesome. But then like once you really try to use it to read the text, or it's getting really annoying. So answer to this question, why do you do something, should be because it helps users. And if the answer like this, then you're on the right track, and that's a good answer. And now I'm going to walk you through a couple of things, how we could use animation to actually help users. And the first thing is a really simple thing. It's help to orient in space. So whenever we have an application, it actually has like different screens, and using animation, you can communicate sort of and build a map in heads of your users. And here's a simple animation of like sliding left and right. And you probably seen it on your mobile phone, like, home screen. And you probably notice that you always have like right edge and left edge, and you cannot, cycle through the screens. This is because you really want to build this map, and it's like in real world, you have to, connect the dots. And example would be something like this. This is an amazing demo from Tom, who he's basically using tabs. And by doing simple animation like this, you're already communicating that you have a certain hierarchy in your application. Second thing is, again, hierarchy, but different level of hierarchy. So here I'm changing animation a little bit, so first screen doesn't move anymore. And it communicates slightly different message here. So we know that first and second screen, they are on different levels. So it kind of communicates that we're probably going deeper into something, into details, and then we can go back. So really simple example here was maps, where you go back, and this animation kind of shows you that it overlays. So third thing, transformations. Here's an example. So when things transform, they do not just like go from one state to another. Oh, does it work? Yes. All right. So here I have like an animation that shows how you open an item. Of course, you could just like, flash the screen with white and then show the next state. But then this like transition will be lost, and of course, user will survive. I don't want to say that, it's really bad, but by using animation, you basically tell the story that something happened to this item, and you are changing its state. All right, the next one is, this is an example again. So this is a concept of, I guess similar to Spotify application, and you see like how you can use motion to communicate that you still, it's basically the same object, it just changes, you're just going deeper or going back. All right, so for number 4, using animation, you can drive attention, and this is really cool because, again, things are moving, and sometimes you want to make sure users following what you're doing on the screen. And here's an example again, where you click somewhere on the screen, then you type a command, and then this message basically goes down and appears up there. It's not continuous animation in this case, but still it drives attention, so I know what's happening on the screen. And last that I'm going to cover here today is engaged users, and this is a really interesting one. Here's an example that I have here. You've probably seen this, it's really famous. So you just type a password, this guy is like hiding eyes when you're typing password. So it's not really helpful if you think about this, but it gives this unique personality to our application, so that you as a user, when you go back, you're like, oh, this application has this amazing thing that I will remember. So animations not always have to be like really productive. Sometimes they can be just fun and tell a story about who we are and why we are different from others. This is an amazing example from Mailchimp. So they're using this animation to warn you that you're going to send emails to, I don't know, 500 people or something, and they're like stressing you out a little bit, which is, people love it, right? Just because it makes sense. And I know that to do something like this, you really need to have design skills. And how many designers do we have here in the room? Do we have any? Oh, we have a couple. Nice. Yeah, everyone has to have a designer friend. Amazing. So, but if you don't have design skills, it's all good. You can always try to animate cats, for example, and people will still have fun, I guess. So it's all good. So let's quickly recap on the first part, which is purpose. Animation should serve a purpose. So help orient space, drive attention, engage users. Of course, there are more. You can find whatever whatever makes sense in your context, but answer because I can is the wrong answer. Okay, let's go to the next one, and this is add a bit of meaning. And it's an interesting part because here we need to talk about what does it even mean to have meaningful animation. Here I have an example. This is scroll animation, and we all get used to the way our mobile phone scrolling, that as soon as someone is like messing it up a little bit, like when someone is like changing behavior just slightly, it's all of a sudden feels weird, feels bad. You're just like, what's wrong with my scroll here? And that's exactly what is meaningful for people, because if in this particular example, my phone built for a certain understanding of how scroll should behave, how objects supposed to move on the screen, and we have to learn and fulfill those expectations. And there are 3 things that we have to take care of. First, it's easing, and we already seen this one in the video. So at IBM, we are defining 2 ways. First is productive, when we don't want to mess with user productivity. It means animation is there, but it's not distracting. It enables people to be productive. And second is expressive. It's time where we want to celebrate a certain moments in the user journey, in user flow. And I have a couple of examples. So here we have a toggle button or primary button animation. Then we have, let's say, a toaster notification that kind of like celebrates something, or might sometimes bring an error, I guess. But we use different kind of techniques here. And the second thing that I want to mention is speed and duration. And again, when we move something on the screen, it kind of has to follow some physics law, I guess. Not one-to-one, obviously, but if object is bigger, then it moves slightly slower. If distance is bigger, then it has to take a little bit more time to get from A to B. So here we have 2 drop-downs. One is like smaller, second is bigger, and we know that they're growing in different. Height is going to be different, so the right one takes more time to actually open, and that makes it a little bit more natural to the end users. Here we have IBM Motion Generator. So this is an open source tool where you can basically play with different values. Here I'm kind of like saying, all right, if distance is bigger, let's say 26, it shows me the duration for the animation and easing curve should be different. I mean, curve stays the same though, but like duration is growing, so that animation is still feels good. And the last one that I want to cover is choreography, and you probably think about something like that, but that's not the case. We are not going to talk about dancing here, but it's still valid. Like the way people dance still affects how we define choreography. So when we animate something, as engineers, we always want to do something like this. We want to use straight lines because it's the most efficient way to get from point A to point B. That's like how we think, and it's totally fine. But when you think about art, about like how people draw, how people dance, you won't see straight lines. When you think about how objects fall from the table or something like that, there won't be a straight line. So sometimes we have to like break this mental model that we have as engineers and really think, all right, maybe in this case it makes sense to move things slightly different. If I inserted an interesting slide where how to debug all these things, like how do you debug speed and motion path and other things in Chrome tools. So they have amazing animation tab, and there you can basically see all the animations that you have on the page. And here I'm running animation at 10% speed. Do you even see it? All right, you see it. And then you can go to 100%, and here you see that I have both transition, bounce, rolling, shadow, all this stuff, and you just can drag and explore how it's going to look. Because here, as you can see, I'm using shadow when ball is like getting closer to the ground, And it's really hard to get this right, just because as soon as it's like slightly off, people start to feel it, like something wrong with this thing. And this is a great way to check how to make it right. All right, so we are done with the meaningful part. And so here's a short recap. Animations should look and feel organically. Keep in mind easing, speed and duration, and choreography. And now we are getting to the interesting part, because we all hear it's ViennaJS, right? So we have to talk about JavaScript. So how to serve code with 60 FPS. This is an interesting topic. And this is rendering a pixel pipeline that each browser has to go through when you animate something. So first you have to run JavaScript, then you have to calculate styles, you have to lay out things, you have to paint and compose. And if you want to get 60 FPS, that means you have 1 second divided by 60, 16 milliseconds per frame. And sometimes it might be hard to get that. Here I have an example. So this is a traditional swipe to dismiss or swipe to remove interaction here, where you need to deal with live. You have to calculate each frame based on user input, and you could solve this problem in different ways. So for example, I could go and do like position relative and left, like left something, but that's the wrong way, because this property is going to trigger layout, paint, and compose steps in the pixel pipeline. But if we look into transform, you will see that for different browsers, it will only use the compose. So the trick one is to use cheap CSS properties, and we basically have two. It's transform and opacity. So always try to use these two, otherwise you will lose frames per second, and yeah, that's tough. I have another example. Oh, right. So, but that's the thing. You basically, by using transform and opacity, you eliminate 2 steps in the pipeline. I have another example. It's a little bit more complicated and interesting. So imagine you have a problem like this. You have a list, and then you want to, you tap on an item, and then it falls down to, some other list. And basically, you don't know how many things you have. You don't know where it's going to land, because there might be items below or not. Let's try to solve this problem. So have you ever heard about flip? Yes, no, yeah, awesome. Some people heard. So this is not a new idea. It means first, last, invert, play, from Paul Levis. Yes. So idea is really simple. You basically pre-calculate everything in advance, and then you run your animation. Sounds simple. Let's go to the next step. Why do we even want to do that? Because there is another acronym here called RAIL. It's a research from Google that says how much time do we have for each thing. So they did study how much time we have for response. It's 500 milliseconds. So if you interact with an object on the screen, and response on the screen has to arrive within 50 milliseconds, otherwise user will notice that something wrong. Animation, 10 milliseconds, again from 60 FPS. Idling, maximize. That's not important. I mean, we have to load content under 5 seconds, but what we're interested in is this response time. So this 50 milliseconds time frame that we have when user clicks on the mouse or taps on the screen, we have this time that we can use to do some math if we want to do animations. So that's exactly what we're going to use in the example. So let's say we have this simple HTML. Can you see it? I can scroll a bit. I think better. All right. So we have a list, and we have some items. That's the list that I've had before. And then we have a panel where this thing will going to fall down. So step number one, we need to subscribe for the events, add event listener for each item, and then I have this handle tap function that I'm going to describe a bit later. So step number one, when you tap on an item, we basically create a new div, and we right away append it to the panel. So it goes right here. And some people might say, whoa, 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 like, is it going to like flicker on the screen so that like you have it there and then you jump somewhere else? Answer is no, just because JavaScript is single-threaded, right? So unless when you run JavaScript, nothing is going to render unless you're done. So you can change properties, you can do whatever, nothing going to appear on the screen yet. So let's go to the next one. That's the main trick of the flip animation. So now I have my target as a original element that I tapped on. This is target. And then I have new element that they just created and appended to the panel. So I have those two elements. They're not still on the screen, but they're in the DOM tree, right? So that means I can force browser to give me their positions. So here I have start and end. Nothing on the screen again, but I have positions. I forced browser to do this. I forced browser to run style and layout, which is expensive, but it's fine because we have 50 milliseconds that users are willing to wait. And I get back values for the start and end position, and I can do all the math right now. So I do start X, start Y, end X, and Y, and I can build a Bezier curve to basically show the line that is going to be a line which the object going to use. So Bezier curve, here I use like start X, start Y. This is all simple. It's basically you have 4 points that you need to describe. A, B, C, D, and that's how you define the curve. I'm using, based on the calculations that I do, I build a curve like this. And why do I need this? Because there is an amazing thing in CSS called offset path, so where I can specify a path in SVG style, and then I just use keyframe animations, and my object will go along a line that I defined before. So really simple, and then really easy to do. All right, now let's actually complete the animation that we wanted to build. So first I need to calculate the ratio. So between start and end position, you probably noticed that it gets smaller when it falls down. So I need to calculate what's the ratio between start and end. It's really simple. I used ratio. I divide width of start by width of end, and then I apply scale transform with ratio. I apply my path as an offset path, and then I define animation, and then I have something like this somewhere in background in CSS saying, okay, from 0 to 50%, just scale it back to the 1, which is like from bigger to smaller, because original thing for new element is a smaller version of it. And then for the 100%, go from 0 offset distance to 100% offset distance. So what's going to give us is basically this kind of animation where we have things falling down based on, and that's again like calculates dynamically based on available space in the bottom panel. However, this solution has a problem. What if I have an object that is like really close? Let's say I'm tapping on the last item, then the distance to the destination will be much smaller. However, timing will be the same, so it won't fill naturally. Let's try to solve this problem by using Web Animations API. And here I'm using a ViennaJS library to basically build path, and it gives me this magic length function that returns how long I need to go along this line to get to the final destination. So path.length give me a distance. And then next step, I'm using magic function get duration. We have this function in Ibm Motion open source package. You can check that out. It doesn't have the same signature. It doesn't have the same parameters. I'm just using here, I'm just showing you that, let's say we have a function that based on distance and size of an object gives us duration, basically timing. Again, I calculate ratio, and then this is a Web Animation API syntax. It's not jQuery or something. You basically have a DOM element, you write .animate, and then you say transform array from scale ratio to scale 1. And then you say scale duration. This is basically time, right? How long does it take to do this animation? Here I have this scale animation on finish. So there will be promises and other better things coming in for Web Animations API. Currently they are not available, so you use this weird callback. But yeah, it's improving. So here I'm waiting for first animation to complete, and then I animate offset distance from 0 to 100%, and then I use a duration and easing and fill that we pre-calculated before. And what we get is this. So now you see that doesn't matter how far or how close the object is, it's still first line is correct, so it goes to the right or to the left, and timing, speed, and duration still makes sense because it's still relevant to the distance that the object has to travel. All right, so bad news. So offset pass is not that. Yeah, situation is pretty bad with different browsers. We are using Electron, so we're building desktop applications, so it's okay for us, but for a different browser. However, there are libraries that have workarounds, so you can use something like Anima.js or other libraries that have polyfills for that. Web Animations API, slightly better. It's not yet complete, it's still work in progress, but many nice things are there, much more coming in soon. Really excited about that one. All right, what if your laptop is still hot? What do? You open your Chrome Performance tab. That's the place where you see all the problems. That's how you debug animations. Here, this green line means I get 60 FPS everywhere, which is great. So in case of troubles, you will just see that it goes yellow or red, and you can check what kind of functions take the most time and prevent you from rendering 60 FPS. One thing, but is this CSS property called will change. It's used wisely. You see its potentially star increases the performance, and with any star text there is like a long tiny font thing saying don't use it please, or stuff like that. So will change basically a hint that you can give to your browser that, hey, you know what, we are going to animate transform for this element, so maybe you could put them on different layers, which requires more memory, but it's up to you. So you never know if browser will take it into consideration or not. But when you do that, you could actually harm your performance if you don't do it wisely. So idea is that you use it only when you are desperate, and you remove it right away after you don't need it anymore. So be careful with that, but might be helpful. So quick recap. Animate cheap CSS properties, like two basically, opacity, transform, really easy. Use first 100 milliseconds. I write here 100 milliseconds because actually research says 100 milliseconds, but because of browser takes some time for different things to respond to a user, to actually give JavaScript the rights to answer, you actually have 50 milliseconds. But yeah, debug and performance animation tabs, test on average devices. So yeah, it's not, if something runs quickly on your i7 thing, latest high-end PC, that doesn't mean anything. You need to test it on average device and mobile device. Some average Android device will be nice. Some useful links. So this is motion guide from Carbon Design System. Understanding motion from material design from Google, amazing material. Motion manifesto, great article on Medium, and a couple of more articles. So yeah, that's great things to read. Let's bring you guys to life. Thank you.